Hello students and welcome back to your second science online lesson. I'm Ms. Rosa and today we will explore the first lesson in Unit 5 of the book. Okay, Unit 5 is about electricity and magnetism. The first lesson in the unit is electricity flows in circuits. Now, the pages of this chapter is from page 72 to 73 in your Cambridge Primary Science book. So please make sure you open your book on that page. The learning objective in this lesson is to learn how electricity flows in circuits to light up a bulb. The important words that's going to come up in this lesson and we need to focus on are electricity, cell, flow, current, complete circuits, and terminal. Now, before we get to the lesson, I want you to imagine a world where you can't turn on your lights, your computer, or there is no fridge to save your food, you can't play video games or even use your iPad. The reason you are able to do all these things now are because of something called electricity.
Whoa, Frank! Electricity, man! It might look cool, but it's really dangerous. It's all around us, powering stuff. In those plug sockets and stored in those batteries. Created by faraway generators, powered by gas, oil, wind and solar energy. Let's get this experiment going. Electricity can produce light, sound, movement and heat. You've created toast? Sweet.
So electricity is a type of energy that flows from one place to another. We have two main types of electricity. One, we have static electricity, and two, we have current electricity. Now, static electricity is created from rubbing two or more objects together and make friction. It's just like when you comb your hair and there's a friction, or when you touch the door handle, there's a little stink to it. That's the electricity. Or when you wear clothes, like you feel little stinks here and there, strings of electricity. That's statics. But current electricity is the flow of electric particles moving from a place to another. It's the type of electricity that we have in our flashlight, TV, laptops, phones, fridge, and air conditioners. Now, let's watch this video to have an idea of what static electricity is.
Hello boys and girls and welcome to Hoopla Kids Lab, making science super fun. Today we're going to be experimenting with static electricity. This is a really simple experiment and all you're going to need is a comb, a balloon, you can choose any colour you like but we've chosen orange, and a piece of tissue paper. First blow up your balloon and then rub it on somebody's head, so preferably someone with a lot of hair. You'll see that the hair sticks to the balloon. This is because rubbing the balloon against your hair creates static electricity, which involves negatively charged particles, or electrons, jumping to positively charged objects. Then take your tissue paper and cut it up into small squares. If you hold the balloon over it, you'll see that it starts to pick up the paper. This is because it has an opposite charge to the electrons in the paper. In this case, it really is true that opposites attract. Now you can try the same experiment with the plastic cone. If you rub it against your hair or against a woolly jumper for a few seconds, you'll see that it charges with static electricity and you'll be able to pick up the paper. And there you have it. That's how we experiment with static electricity.
Okay, let's look more into current electricity now. Your flashlight, laptop, fridge, video games, these things all work because of current electricity. And to understand the current electricity better, we will look into the simplest example we have here, which is this torch or flashlight. Flashlight and torch both have the same meaning. How do you think this torch works? Now, if we look inside the torch, we can see that there are batteries in there. These batteries are the source of energy and we call them cells. So cells are a source of energy that pushes electricity around. The flow of electricity in the torch is similar to the flow of water in a stream. Just like is shown in the picture, electricity, or we can say charged particles, move continuously from the cells in one direction and we call that a flow. So the flow of charged particles is called an electric current. Electric current is the flow of charged particles traveling along a path, and that path is called a circuit. A circuit is the path where the electric current can flow. Now, the electric current should be able to flow in a complete circle in order for the bulb to light up. Circuit sounds like circle because just like a circle, it goes round and round. We should not have any spaces in the circle or in the circuit we have here, in the flow of energy we have here. Otherwise, the energy or the electric current will not be able to flow. So a complete circuit is the path where the electric current can flow all the way around. As we can see, if we have a space in the circle, we have a space between the flow of energy, between the electric current, we will not have any flow of energy anymore and the bulb will not light up. Now, you might notice that each cell inside the torch has two ends, a positive end and a negative end. These ends are called terminals. A terminal is the positive or negative end of a cell. If we have more than one cell, more than one battery, just like in this picture, in order for the torch to work, in order for the bulb to light up, we need to arrange the cells in a way that the positive end is against the negative end. But the question is, why? Now you see the negative end pushes the charged particles away and the positive end pulls the charged particle. So just like that, we will have a complete flow all around the cell. If we put two positive ends against each other, just like this picture, this end pulls the energy and this end pulls the energy. That way we don't have any flow of charged particles around here. And if we put two negative ends against each other, just like in this picture, this this end pushes the energy and this end does the same. So we will not have any movement, any flow around here. So the only way is to put the positive end against the negative end so we could have a flow of energy all around, just like it's shown in this picture. Now, in page 73 in your books, we have a point of discussion that says, talk about what things do you use that needs cell. It asks us about the daily stuff we use that needs cells and batteries. I will not give you the answer directly. Instead, I will show you a video about cells and leave you to write your own answers in your notebook.
Batteries come in all different shapes and sizes, and we use them to make lots of things work. Batteries can be used together to provide more power to drive things. There are tiny batteries for watches, larger ones for remote controllers, torches, and these fairy lights. But imagine how many batteries you would need for these lights.
Before we revise the vocabulary in the lesson and move on to the focus points, I thought it would be a good idea to discuss the questions in your book. This is page 73. Now, we have two questions. Question 1. What happens if you put the positive terminals of the cells in a torch together? Will the bulb light up? Now, what do you think? Based on what we've learned so far, we know the bulb will not light up, the electricity will not work. Why? Because we have two positive sides together. We know the electric current will not happen if we put two positive sides or two negative sides together. So the answer is the bulb will not light up. Number 2 is explain why the cells in a torch have to be arranged with the negative terminal of one cell against the positive terminal of the other cell. We explain this as well. The answer is because the negative terminal pushes the energy, pushes the charged particles, and the positive terminal pulls the charged particles. Because of the pushing and the pulling, we have a complete current, a complete circuit of the electric current. And if we move on to your activity book, this is your activity book, I believe, let me see, it is page 43 in your activity book. Let's read this question and discuss. In this exercise, you will apply what you know about electric current flowing around a circuit. Raphael's baby brother has a cell-operated toy car. The toy needs two cells to make it work. Raphael puts two cells into the car, but it doesn't work. Raphael's brother starts to cry. Then Raphael takes the cell out, turns one of the cells around, and puts them back in the car. This time the car goes. Raphael's brother is happy. Question 1. Why didn't the car go when Raphael put the cells the first time? Why do you think so? The answer is because there might have been two positive ends together or two negative ends together. Why did the car go when Raphael changed the cells? So here, the car went when Raphael changed the cells because Raphael put the positive end of one cell against the negative end of the other cell. Here's a drawing of the inside of the toy car. A, mark the positive and negative end of the cell. This is the positive end and this is the negative end. The one that has this little dot over here, I don't know if you can see this one, it's always the positive end. B, draw arrows to show the path of the electric current. Now, what I want you to do in your books is draw the complete circuit that shows the electric current. Okay, these were the important words we needed to know in this lesson. Now, let me see if you can remember the meaning of these words without looking at your book. Pause the video and write each word in your notebooks with the definitions. Welcome back to the video. Now let's move on to the focus points of the lesson. The first one is electric currents are the flow of charged particles in a circuit. Electric currents flow in complete circuits from the positive end of the cell to the negative end. The circuit must be complete in order for the bulb to light up. If we use more than one cell, we should arrange the cells in a way that the positive end of one cell is against the negative end of the other one. Okay guys, this is the end of our lesson today. Hope you enjoyed it and understood the material well. If you have any questions, feel free to ask in the comments. Stay safe and see you next lesson.